Inverses. Here's what inverse means. If I have, tell me if you can figure out. If I have the point 5, negative 7. The inverse of that point is negative 7, 5. What happened? What flipped? X and Y. Okay. That is, by definition, what it means to be inverse, okay? X and Y. We'll say flip. Or switch. All right, so if I've got a set of points, it's really easy to find the inverse because I take what was X and make it Y and what was Y and make it X. That's an easy concept, right? Right? Okay. So let me show you graphically what this looks like. Let's say, let's take a parabola. This is that parent graph that you're so familiar with. 0, 0, 1, 1. You can't see? It went off? Well, poo. Look at this parabola. So you can think about this on a bigger scale or on a point scale, thinking about like the points. If I switch the X and the Y axis, think about what that graph would then look like. So if the y-axis became the x and the x became the y, think about how the picture would change. Close, close. Just so you can see, let's do this. Let's take these points that we know are on the green, and let's switch x and y and see what happens. 0, 0 becomes 0, 0, right? It's still 0, 0. 1, 1 becomes what? 1, 1. Negative 1, 1 becomes 1, negative 1. What's happened to my parabola? It went on its side. It turned. Yep. Do you see? Okay. Now, a rotation. That's exactly right. So now if you think about it, where the y-axis was, it became the x-axis. Right? So it just switched x and y is what it did. So that's what it means to be inverses. While I'm here on graphs, when you look at a graph, and I say, look at the following picture. Y'all got this? Oh. You a graph that looks something like this. And I said, is this a function? What would you tell me? Why? Vertical line test. Good job. What if I asked you if the inverse of this graph is a function? Why? You're exactly right. If I flip it, it's going to do something like this, right? Which means it would fail the vertical line test. Can you think of a way to test it without flipping the graph? Come on, y'all can do this. You change your test line. Vertical line test to see if it's a function, right? So if you made it a horizontal line, it would test to see if the inverse was a function. All right, let me give you one. You tell me. Oh, sorry. Were you? I'm sorry. This was on your test. One of your parent functions. You remember what that is?
I think, yeah, I got this one.
You do know the domain?
Yeah.
Uh-huh. Good. You don't remember the function though?
It was the third one, eh?
1 over x. You just remembered them by the order they were in on the packet? Oh my goodness. Okay. This is 1 over x. Is this a function? Why? Passes the vertical line test. Is its inverse a function? Why? It still passes the vertical line test. Or, the way it sits now, it passes the horizontal line test. If you took a horizontal line here anywhere, it would still pass. Okay. So it's a function and its inverse is a function. Does that make sense to everybody? Okay. Let's talk about algebraically. All right, algebraically. Let's say I have the equation. I'll do an easy one. All right, so if I want to find the equation algebraically, same thing I do whenever I'm looking at coordinates in a graph. I'm going to switch x and y. Only this time, I'm going to solve it for y once I switch them. So I'm going to have x equals 2y plus 3. And so how do I solve that for y? Minus 3. And then what? Divide by 2. These two are inverses of each other. Does that make sense? Yes. Yes, we did. Let's see. Let's make one a little bit harder and see if you got it. By the way, sometimes we will say, you know how we have f of x is the same thing as y? It tells us that it's a function. Inverse of f of x, we write like this, and it means the inverse of f. It's not an exponent of -1, it's the inverse of f. So if you see that, that's what that means. All right, let's look at this one, see if you can find the inverse here. Let's say f of x equals the square root of x to the third plus 2. And I said find an equation for the inverse. Tell me what you do first. Flip x and y. I don't see a y though. F of x is y, right? So I'm going to make this x equals square root of y to the third plus 2. What can I do now? Square both sides. So I get x squared equals y cubed plus 2. How do I get rid of a power of 3? Third root. That's exactly right. This cancels out this. Make sure you do the whole side. Make sure you're going opposite order of operations as you solve here. Where does that class go every day?
They just call
All right, so I got the cubed root of x squared minus 2. That is what equals the inverse. Now, we have to think about domain. We always have to think about domain. I don't know. You want me to look? What's the domain? Oh, I'm hesitant to ask this. What's the domain of f of x? Before I look at the inverse here. Close. I've got a radical there, though. And what happens with radicals? That's a fraction. The bottom can't equal 0.
It can't equal
It can't equal. You're on the right track. It can't have a negative under there, right? So x to the third plus 2 has got to be bigger than 0, right? If I solve this for x, I've got x cubed is greater than or equal to negative 2. And then how did you say I get rid of this third? Can you take the third root of a negative number? Ooh, think back algebra 2. Yes. Because if you think a negative times a negative times a negative still gives you a negative, right? The reason we can't do it with even roots is because a negative and a negative is always going to give you a positive. But with odd roots, a negative, and a negative would give you a negative, okay? So here, this is saying that x has got to be greater than or equal to the cubed root of negative 2. I'm not even going to focus so much on what that value is. It's going to be a crazy number. Does this have any restrictions? It's a cubed root, not a square root. Does it have any restrictions? No restrictions on cubed root. Think about your, under the radical, the third power, remember we can take a negative under there. So I don't have to set it bigger than or equal to 0. So what you have to do with these is just like when we were doing the composition, just like when we were doing the addition, subtraction, and multiplication of functions, you have to do what we call a combined domain. You have to look at the domain of the first and the last and put them together. So since this is all real numbers, but this one is restricted, that means my domain has to be greater than or equal to this. So from here to infinity. It looks terrible, but it's really not that bad. This is just a decimal you can get on your calculator. Here's what you got. You look for fractions and square roots. If it's a fraction, leave that number out that makes the bottom 0. And if it's a radical, set it greater than or equal to 0. Yeah. Yeah. All right, I got one more thing to show you and I'm done. Yeah. Oh, like the decimal equivalent of it? No. No, leave it just like that. No. All right, one more thing. Verifying inverses. This, again, we did in Algebra 2. When you have two functions that are inverses of each other, okay, let's say, I'll just do a really easy one. I'll do that very first one we did. What was it? 2x plus 3. And when we found the inverse, what did we say it was? X minus 3 over 2. Okay. When two things are inverses of each other, in other words, if I told you that f and g are inverses, something special happens, and we have to verify this way. We have to show one step at a time. One step at a time. Thank you. That's at.
No, the A. Step at A.
A time.
Yeah.
Thank you. All right, we have to show that f of g of x reduces down to x, and g of f of x also reduces to x. So this is composition that we did on Monday. So plug each one into the other, and what's going to happen is hopefully everything's going to cancel out and it's just going to leave you with x, but you have to show one step at a time. All right, so if I do f of g of x, and I'm just putting this here because g of x is x minus 3 over 2, right? Right? Okay. So this becomes 2 times, do you still see the original equation there? 2x plus 3. Now, I'm telling you everything's going to cancel out. But don't just cancel it all out at one time. What cancels first here? The 2's. Multiplication first. Yeah, this is what you have to show. Now what cancels? The 3's. This is one of those things where I'm telling you what to start with. I'm telling you what it's going to equal. Your job is to show me all the middle steps. Backwards and forwards, because it's only verified if it does both ways. So this time 2x plus 3 goes into g. So I have, remember it's x minus 3, so 2x plus 3 minus 3 over 2. What cancels first? Ooh. Order of operations, the 3's are going to cancel first because what happens is fractions group things together, top and bottom, so you need to try to simplify anything in the top first and then anything in the bottom separately. So the 3's are going to go first. That leaves me with 2x over 2, which clearly then reduces to